talk on parametric equations. We understand that certain mathematical functions can be expressed more simply by saying x and y separately in terms of a third variable. For example, let's say that x is r cos theta and our y is given as r sin theta. Now, the third variable theta we have in this case is called a parameter. Therefore, the two expressions x and y are called parametric equations. Now, if you look at this now, this is the parametric equations for a circle. For a circle, we understand that the equation of a circle at any point, okay, the equation of circle at any point is given centered at origin. Okay, this is centered at origin. Is given by x squared plus y squared is equal to r squared. So let's do this. Our x is r cos theta squared. Our y is r sin theta squared. Will it give us r squared? We'll find out. So this will give us r squared cos squared theta plus r squared sin squared theta. Factorizing with r squared, we have cos squared theta plus sin squared theta. Now, according to trigonometric identities, cos squared theta plus sin squared theta is equal to 1. So this is r squared. Now, there are also several forms of parametric equations. Now we have considered circle. For circle, x is r cos theta and y is r sin theta. Okay, and it is centered. If it's centered at origin, we have something like this. Another example is ellipse. For the ellipse, x is a cos theta and y is b sin theta, and the graph is similar to this. Another example of parametric equations is the hyperbola. And for the hyperbola, we have our x to give us a sec theta and our y to give us b tan theta. And the hyperbola looks like this. This is the graph of the hyperbola. And finally, let's take another common one, which is the rectangular hyperbola. The rectangular hyperbola have x to be equal to ct and y to be equal to c over t. And the graph of the rectangular hyperbola looks like this. In our next video, we'll be talking on how to differentiate parametric equations and more, not just differentiating the first time, but also differentiating it the second time to evaluate the y, the x, and to evaluate the square y, the x squared.